Okay, so again, there'll be a blank template posted out on Canvas of this that you can go back and rework if you want to, and then I'll do a PDF of the solutions and post after the class. So basically, and we're going to go back to productivity here, right? So, and then at the top of the exam, you'll say round your answers to 2 decimal places and show your work for partial credit, okay? And that applies to every problem. So if I'm going to calculate the labor productivity for last year, so I'm given this information for last year and this year. One of the first things I want to make sure that you remember is we talked about productivity measures in terms of 3 types of measures. We said we had partial productivity, multi-factor productivity, and total productivity. Okay, so partial productivity. Okay, productivity. The formula for productivity. Do you remember it off the top of your head?
Sales divided by whatever it is you're trying to figure out the productivity of.
So even more generic than that, you would say outputs divided by inputs. Okay, and so partial productivity. How many inputs are you working with?
One.
Multi-factor productivity is more than 1, but not all, and total productivity is just saying you're using all, okay? So again, that's kind of that breakdown of those 3. So if I'm going to calculate the labor productivity for last year, which is a partial productivity measure, because I'm only using 1 input, right? I'm going to use, so again, it's outputs divided by inputs. So in this case, it's going to be my output of sales of 201,000, right? And I'm going to divide that by labor from last year of 30,100, and that's going to give me my productivity measure. I'm going to use the magic of, right, I've already done the calculation, so it's 6.67, right? And so that reminds me, you need to bring a calculator, okay? I have 4, and please just be that person that brings a calculator, okay? Because if I have 6 people that don't bring calculators, then 2 of you are waiting until the end of the exam, and then it probably won't be stressful this time, but when we're time crunched, that can get stressful. So just bring a calculator, okay? And I'm going to divide this across 2 rooms, so we'll have half in here and half in the room next door. And we'll just do it alphabetically, and that way you can be every other seat, and you have plenty of room to work, okay? And so that's how we'll break that up. All right, so far so good, right? And then the next one says, calculate the multi-factor productivity for this year, including the inputs of labor and raw materials. So again, if I say productivity is outputs divided by inputs, and my output from this year is 203,000, and I'm going to divide that by the inputs, and so this would be a multi-factor productivity because I'm using both labor and raw materials. So I'm going to use labor at 40,100 plus raw materials of 45,100. So the key on this type of a problem is just make sure you're using the data from the right year and that you capture the right outputs and inputs. So that becomes 203,000 divided by 85,200, which is then 2.38, which is your productivity measure. Okay? So again, relatively straightforward. Okay, so now we start into some of the forecasting problems, right? So a company wants to forecast demand using the simple moving average. So if the company uses 3 prior yearly sales values, for example, year 2011 is 250, 2012 is 260, 2013 is 290, which of the following, sorry, that's changed. What is that, right? So what is the simple moving average forecast? Okay, so how do I figure that? So let's start in the front row, and it's Kaylee, right? Callie?
Haley.
Okay, sorry. Callie and Kaylee. So Callie, how do I figure this? I'm looking for the simple moving average.
I don't know.
Simple moving average for 3, so we've got 3 years. Morgan, what do I do?
I have up to 3 years and divide them by 3 years.
Right, I'm just taking the average, right? 250 plus 260 plus 290, sometimes plus 290, and divided by 3, right? And so that simple moving average, again, I pre-worked the math, is 266.67, okay? Okay, all right, so then, Taylor, Given a prior forecast demand of 460, a related actual demand of 420, and a smoothing alpha of 0.3, what's the exponential smoothing forecast? And you'll get the formula, which says that the forecast for the current time period equals the forecast from the previous time period plus alpha times your error, right? Which is your actual from the previous time period minus your forecast. Okay, so Taylor, help me plug in the numbers. My forecast from my previous time period was what?
Is it 420?
Given a prior forecast demand value of 460.
Okay,
So 460 plus my alpha of
0.3.
0.3 times my actual minus my forecast.
So 460 minus 420.
Maybe actual is
Oh, okay. 420 minus 460.
420 minus 460, right? So it's the key of making sure that you're clear on what's what, and then it's just plug and play, right? So in this example, again, it's going to be my forecast for the current time period is the forecast from the previous time period times alpha plus error plus my error, sorry, let me rephrase that, plus alpha, which is times my forecast error, which is my actual from the previous time period, minus my forecast from the previous time period. And so when I plug and play that, it becomes equal to 460, sometimes 460, plus my alpha of 0.3, right, times 420 minus 460, which is then equal to 460 plus 0.3 times negative 40. Which if I finish that math out then is 448. If I've done that right. Okay. So again, that's the only formula you're going to be given on the exam is for exponential smoothing, right? The rest of it you need to be familiar enough with to get it, okay? Then, because when I say a 3-month moving average, I expect you to know that I'm just going to take the last 3 months and I'm going to average out those values. I think that's overly complex, okay? And then we're going to do, as a consultant, you have been asked to generate a unit demand forecast for a product for year 2014 using exponential smoothing. The actual demand in year 2013 was 1,000. The forecast demand in year 2013 was 1,200. Using the data and a smoothing constant of 0.3, what is the forecasted value? Okay, tell me your first name again.
Ryan.
Ryan? Okay, Ryan, help me out with that one.
Okay, so you would plug in that same equation, correct?
Correct. So we're using exponential smoothing, so it's the same equation.
So the forecast demand was 1,200, correct?
Mm-hmm.
And then plus 0.3 and times parentheses 1,000 minus 1,200.
There we go. Okay. So then it just becomes equals 1,200 plus 0.3 times negative 200. Okay. I'm going to finish that out. That becomes 1,140. Okay. All right. All right, so now we're going to get into, do you remember what we know about our regression equation, right? So the regression equation that we've used is y is equal to a plus b times t, where y is what we're trying to predict, a is the intercept, right, and b is the slope, okay? So the question is, then, Zach, I'm going to come back to you. So the question is, Zach, for every 1 unit change in time, right, because that's what we're using as our independent variable for t, the forecast will increase by how many units? So this is just kind of, do you understand what we're saying with the with the regression equation.
Why?
Nope. Okay,
84?
okay, nope.
It's 9.
Ethan's got it, it's 9, okay?
Oh.
Because you think about, if I only change this by 1 unit, so if it goes from, if it's at 0, right, y is 75, right? If it's at 1, it's 75 plus 9 for 84. If it's at 2, it's gonna be 93, right? Because you just keep adding 9 every time, okay? And so that's what the slope's doing. That tells you every time I change by 1 unit of whatever my independent variable is, that's how much it's going to affect the dependent variable, okay? Right? The other question is, given the above time series regression given the above time series regression equation, what is your forecast for time series 20? Okay, so Kyle, let's come to you.
What?
How would I figure that?
Y equals 75 plus 9 times 20.
There you go.
Whatever that
75
answer
plus
is.
9 times 20, right? And so that's going to be, again,
75 plus 180.
75 plus 180, which is 255. Right? Okay? And so I'm just going to, again, finish this one out. So we said that the forecast, or Y, will increase the value of the slope. Okay. And in this example, the slope is 9, so forecast will increase by 9 units. You only have to answer 9, right? I'm only doing that so if somebody's looking back at this for reference, they understand that. But you just have to answer that question directly. Okay. Xander, the company hires you to develop a linear regression forecasting model. Based on the company's historical sales information, you determine the intercept value of the model is 980. You'll also find the slope value is minus 25. If after developing the model you were given a value of x is equal to 12, please calculate the resulting forecast using this model. So first off, let's get the equation, right? So y is equal to what? Just tell me generically.
Intercept times the slope.
Intercept plus slope
Plus slope.
times our x, okay?
Just 12.
Okay, so then if I'm going to just sub in, so the first thing is, don't get overwhelmed by what's there. Think, okay, well, if I'm using a regression equation, that's the formula, right? And so now that I know that, tell me what the intercept is.
So it would be 980 plus 25.
Plus
I mean,
minus 25.
minus 25 because it's,
Mhm.
and then times 12.
Yep, there you go. And then you just solve it. So it's not as hard as you first thought, right? So then you're going to finish that out, and it's going to be 980 minus 25 times 12, which is 600. Okay?
That was weird.
So don't forget to watch for that sign error, right? Because that can catch you. All right? Khalid. Manager has utilized the following multiple regression equation incorporating price and advertising as independent variables. The manager would like you to predict demand at price for $750 per unit and advertising for $800 per unit. How am I going to solve that? Do you know?
I think you the average for each season.
Okay, no, you're looking down here, and we're up here. Okay, so this is a different problem. So basically, we've been given this multiple regression equation, right? And we've been given some information about it and asked us to predict what it will be based on that information. Okay, so we know that price is $750 and advertising is $1,800. How do I solve for that?
So it would be 1,800 plus.
Nope. Okay, I'm using this equation.
Okay.
So I have to use the intercept plus the slope of price times price plus the slope of advertising times advertising. So if you look, then what we know is, so it's 1985 plus negative 2.20.
What's the price? 750.
So what's the price?
750
Right. Plus
plus 20 multiplication.
times,
8.
there we go. Okay. And if we were gonna finish that out,
Do some maths.
it becomes 1985 minus 1687.50 plus 396, which then is 693.50. Okay? Allie Kaylee, right?
Yeah.
I like, it's not been that long, it's been less than 10 minutes. Okay, so Kaylee, so you get one of the harder ones, sorry.
Thanks.
Maybe not, depending on, because we just did it, so maybe it won't be too hard. So what we want to do is we want to figure out what the seasonal factor for spring is. So can you help me out with what's the first step you would do if you were trying to find a seasonal factor? We'll spread the love.
Don't you take the average of you take the average of spring both times?
Okay, I'm going to see if I can actually insert into a table here. Let me just try to change this layout real quick.
Spring's 500, summer's 225.
Okay, so that being said, so you're saying I need to take the, tell me again?
Take the average of 400 and 600.
Right, divide that by 2, so we should get that to be 500, right?
Mm-hmm.
So if we were doing the whole problem, I can continue to do that and take the average, but you're only asked to do it for spring, right? Okay, so now Tyrus, now that we've got our average for spring, what's the next thing I'm gonna do?
You'll want the average for the,
I'm sorry, we've got the mics going too, so whatever you're saying is getting picked up on that.
Oh, I was doing the problem.
Okay, so Tyrus, go ahead.
you'll want the average of all of them, and then divide the total average by the spring average.
Other way around, but you were close. So we're gonna take this average, right? And so I'm gonna sum everything up here, and I know that that sums to, it's a little messy, but you'll get the idea, 4,950. And how many seasons do I have?
4.
I have 4 seasons, but I just have 8 time periods, right? So I'm gonna divide by my 8 time periods to get that average, 618.75, right? And to get my seasonal factor then, I'm going to take my 500 and divide it by my 618.75. That's going to be 0.808 or 0.81 if we're rounding off to 2 decimal places, right? And so now that's the seasonal factor, right? So again, I'm not asking you to do the whole shebang, right? But I'm asking you to kind of chunk it out and do it in small pieces, okay? Is it Aaron? Okay, Aaron, let's look at the next one then, because it's another piece of that puzzle. So, given an actual demand for the fourth quarter of 1,900 units and a seasonal factor of 0.85, right? What's the deseasonalized demand for that period? So when I deseasonalize demand, what do I do?
Isn't it just the total divided by the seasonal factor?
It is exactly that. So it's equal to 1,900 divided by 0.85, which is 2235.29, right? So again, it's just checking to see if you've done your Connect homework, you should be completely on board with deseasonalizing is dividing, right? And Kirsten, reseasonalizing is what?
Multiply.
Multiplying, right? So then that's the next one. So it says, given a deseasonalized forecast of 2,200, and a seasonal factor of 1.2, right? What is the reseasonalized demand? So what am I going to do, Kristen?
2,200 times 1.2.
There we go. And so my reseasonalized demand is 2,640. Okay? All right, so I told you there would be 11 short answer problems. Those are 11 short answer problems. Feeling a little better about that after we went through them?
Oh, that's the short answer?
Yeah.
Oh, I thought it was like written.
No, short answer problems. So they're just kind of short components of what your Connect homework was. I did want to remind you though that There's a couple of, in the multiple choice, there's a couple of problems in there. So I would again review that chapter 2 homework and make sure that you're up to speed on the percent change in productivity, right? Remember that percent change in productivity, you use the most recent minus the not the most recent, and divide by not the most recent, right? Just make sure that you're comfortable with what direction those things need to go. So review that chapter 2 homework and connect for that. Do you have any questions for me about the exam?
So most of it's just conceptual, just definitions pretty much.
So there are 46 multiple choice questions worth 2 points each, and there are 11 problems worth 3 points each, and I think that comes up to 128. And Blake,
Mike. You rounded 2 decimal points. Is that what you're looking for on the test, or will you have it specified?
yeah, and so it says at the top of the problem section, and then let me just repeat that for everybody. Hold on just a second. Guys, hold on just a second. Round your answers to 2 decimal places and show your work.
Okay, I didn't see
Show
that.
your work, I can give you partial credit. If you don't show me your work, there's no partial credit. It's either right or wrong.
Cool.
Okay? Did you have a question, Kristen?
Yeah, on Connect, you're not allowed to see the homework that you've already like turned in. So, like, you said